Another day, another story. Climate change is a pressing global issue that has captured the attention of scientists, policymakers, and the public alike. It refers to the long-term alterations in temperature patterns, weather events, and ecological systems on Earth. But what exactly is the science behind climate change? In this blog, we will delve into the fundamental principles that drive climate change, the role of human activities, and the evidence supporting this critical scientific consensus. The greenhouse effect. At the heart of climate change lies the greenhouse effect. The Earth's atmosphere acts like a blanket, trapping certain gases and preventing the escape of heat into space. This natural phenomenon allows life to exist, as it maintains a relatively stable temperature on our planet. However, human activities have increased the concentrations of greenhouse gases, such as carbon dioxide, CO2, methane, CH4, and nitrous oxide, N2O, which intensify the greenhouse effect. Human activities and the carbon cycle. The burning of fossil fuels, deforestation, industrial processes, and agricultural practices have significantly increased the levels of CO2 in the atmosphere. Carbon dioxide is released when fossil fuels like coal, oil, and natural gas are burned for energy. Deforestation, on the other hand, reduces the planet's capacity to absorb CO2 as trees play a crucial role in carbon sequestration. These human activities disrupt the natural carbon cycle, leading to a buildup of greenhouse gases and amplifying the greenhouse effect. Global temperature rise. The increased concentration of greenhouse gases in the atmosphere contributes to global warming. Over the past century, Earth's average surface temperature has risen by approximately 1 degree Celsius, 1.8 degrees Fahrenheit. While this may seem like a small increase, even minor temperature shifts can have far-reaching consequences for our planet's delicate ecosystems and weather patterns. Extreme weather events. Climate change has already begun to manifest in the form of more frequent and intense extreme weather events. Heat waves, droughts, hurricanes, floods, and wildfires have become more common in various regions around the world. These events not only threaten human lives and infrastructure but also disrupt ecosystems, agriculture, and water resources, posing significant challenges for societies and economies. Ocean acidification and rising sea levels. The excess CO2 in the atmosphere not only affects temperature but also leads to ocean acidification. As the oceans absorb CO2, they become more acidic, endangering marine life, coral reefs, and shell-forming organisms. Additionally, the melting of land-based ice sheets and glaciers contributes to rising sea levels, which pose a threat to coastal communities and ecosystems. Scientific consensus and evidence. The scientific consensus on climate change is overwhelming. Multiple studies, computer models, and observations from various scientific disciplines support the conclusion that the Earth's climate is changing due to human activities. Climate scientists analyze temperature records, ice cores, tree rings, ocean currents, and satellite data to reconstruct past climates and predict future scenarios. Conclusion. Understanding the science behind climate change is crucial for addressing this global challenge. The accumulation of greenhouse gases resulting from human activities disrupts the delicate balance of Earth's climate system, leading to rising temperatures, extreme weather events, ocean acidification, and rising sea levels. The scientific consensus underscores the urgency to reduce greenhouse gas emissions, transition to renewable energy sources, preserve natural ecosystems, and adopt sustainable practices to mitigate and adapt to the impacts of climate change. By embracing science-based solutions and collective action, we can strive to create a more sustainable and resilient future for generations to come. Thanks for watching.